So our goal too is to graph linear and absolute value inequalities. So now that we've been practicing graphing absolute value graphs a bunch, now we're going to have to graph not only, I don't know why I brought my first name. I meant to write Mrs. Fox, but I just started writing my name. Yes, that is my name. There we go. That's what you guys call me. So our goal is to graph linear and absolute value inequalities. You should already know how to graph a linear equation, okay? In slope-intercept form or point-slope form or standard form. We practiced that in 2.2. And then the absolute value equations, we've been practicing those. We practiced those last week in 2.5. We continue practicing them in 2.6 by noticing what the shifts or translations, those are the same word, along with the stretches. Okay, so that's what that assignment you guys were working on earlier today was. Next, we're going to be doing these, but with inequalities. So what is an inequality versus an equation? What changes in an equation to an inequality? Go ahead.
It changes from an equal sign to less than or equal.
Yes, it changes the equal sign is now going to be like a less than sign or a greater than sign, or a less than or equal to sign, or a greater than or equal to sign. So it's going to have, the sign is going to change, okay? So a linear inequality is an inequality in two variables whose graph is a region of the coordinate plane. Okay, so the way that we're going to first do this, I'm going to do this at first with a pencil so I can erase it. Actually, I'll use this erasable pen. If this said y equals negative 3x plus 4, what is the slope of that graph? What's the slope of this graph? M is going to be negative 3. Where's the y-intercept? Now remember, some people are still losing points because they're not writing their y-intercept as a point. It has to be a point. So where is the y-intercept at?
0, 4.
0, 4. Okay, so when I plot 0, 4, I'm not going to move to the left or right at all. I'm just going to go up to 4 and I'm going to put a point. Okay, and then my slope, negative 3, tells me I'm going to go down 3. Well, you have to be careful, because I went by 2's on here. So this is 2, 3, to the right 1, which is right here. Down 3, right 1. So I'm just putting these points on my graph. I'm going to go in the other direction as well, so I make sure I have as many points I can get to fit on here. So that looks pretty good. Now that I have the points that would create this, I'm actually going to erase this because it's not an equal sign. What it actually is it says it's less than or equal to. So since this is y is less than or equal to, we need to make a note that if it's less than or greater than, these we're going to use a dashed line. Okay, so if it is less than or greater than, we use a dashed line. If it is less than or equal to or greater than or equal to, we use a solid line. So when I go to connect these, am I going to use a dashed line or a solid line? Solid, because it has or equal to underneath. So I am going to use my straight edge. Okay. And now if it's less than or equal to, now I have to also have shading on my graph. And so you can do this a couple different ways. If it says less than, y is less than where? Where are y values less than? Look at the 4. Where's y less than 4? Is it below the 4 or above the 4? Below. And that's exactly what you're reading. Y is less than or equal to. So we're going below the graph. So what I like to do is I go right on the line and I draw arrows going down. Because if it's y is greater than or y is less than, you're going up or down. Because your y-axis is going up or down. That's the side that you color on. The arrows might seem unnecessary right now, but when we get into having to graph multiple inequalities on the same graph, systems of inequalities is what it's called, later on in Unit 3, it's necessary that we have this. So because of that, it's important right now that you put those arrows on there, because now it's very obvious where we're going to shade on our graph. Anything below that line is part of the solution. So we shade all of that. Okay. If it is a solid line, it's part of the solution. If it is a dashed line, it's not part of the solution. Okay, so I'm going to give you an example. Is 4, 2, which is this point right here, is 4, 2 part of your solution? No. Okay. Is -2, -4 part of your solution? Yes. The shaded region is your solution. This is part of your solution. So if you're asked, is -2, -4 part of your solution, you have to answer yes because it's part of the shading. Okay? How about 0, 4? Is 0, 4 a solution?
Yes.
And that's the tricky one because it's on the line. So you have to ask, if it's a solid line, then it is part of the solution. But if it's a dashed line, it would not be a part of the solution. This one's a solid line. So is 0, 4 a solution?
Yes.
Yeah. Yes, it is. Yes.
So, if you just had like a broken up line
A dashed line?
or dashed line, you don't shade the graph.
You still have to shade the graph, but the line itself is not part of the solution. You'll see it in the next one.
So if you have a solid line and say you have 0, 4, if the 0, 4 falls on the solid line, then it's part of the solution.
Yes.
If it's a
So
dashed line, falls
then it would be
on the
no.
line, then it's no.
Yes. So if you're talking about if it's asking is 0, 4 a solution and it's on a solid line, your answer is yes. If it was on a dashed line, you'd answer no. Either way, you're going to have shading. Anything in the shaded region is a yes. Anything in the unshaded region is a no. Okay?
That's just because.
Because if I plug it in, okay, if I plugged it in up here, if I plugged in -2, -4, I'd have -4 is less than or equal to -3 times -2 plus 4. And I simplified on the left, I'd have -4. When I simplify the right, I have -6 plus 4, or I'm sorry, +6 plus 4, which is 10. Is -4 less than or equal to 10? Is that true? Is -4 less than or equal to 10?
No. Oh, it is less than.
-4 is definitely less than 10, right? So that's true, which is why when I plugged in -2, -4, it's a solution. it makes the inequality true. And that's what we're working with. When we were working with equations, the solution to an equation is the point that when you plug it in, it makes the equation true. Well, there's not just one point or a series of a line of points that make this equation true. There's a whole region of points that will make this inequality true. And it's any point that's in that shaded region. If I plug it in, it'll tell me it's true. Yes?
So can we just plug in numbers to the equation instead of like having to do all the shading stuff?
That would be a lot of numbers to plug in because you right here, look at, you have negative 4, 12 to plug in. You have negative 4, 8 to plug in. You have all the points in between those 2 points to plug in. I don't think you want to plug in every single point on the entire graph.
So you can just plug in one and like the other half and see if it's true or false, right?
Are you saying if you don't know which direction to shade?
Yeah.
You can do that. Well, and super easy point to plug in is 0, 0. And if it works, then you know you're shading towards the area of 0, 0. Does that make sense?
Yeah.
Okay. So yes, you can do that. You can pick a point and say, does 0, 0 work? It does. So I'm going to shade in the direction of 0, 0. And then you know if you're shading below or above. You could do it that way too. Yes.
So, and then let's just say you make it 4 is greater than or equal to 10, and it might be a solid line, but that wouldn't be part of smoothing.
If that said negative 4 is greater than 10 and it's false, then that would not be shaded. That point should not be shaded. Okay. All right, so let's try this one. This one, it's just strictly greater than. Okay, not greater than or equal to, just greater than. Now this is in point slope form. So what point was used to write this equation? So now we got to go back to our 2.2 information here. What point was used to write this equation or that inequality? What is it? Not negative 4 or 5. Remember, your x is with your x, your y is with your y, and they show up opposite. Go ahead. Yes, negative 5, comma 4 is the point. And what is the slope of this graph going to be? Yes, negative 2/3. So we're going to use those pieces of information. We're going to plot negative 5, 4, which is right there. And we're going to go from there and we're going to use the slope negative 2/3. So down to right 3, down to right 3. And I'm going to keep going until I run out of space on my graph. When I go to connect these points, should I connect it with a solid line or a dashed line? A dashed on this one because it's strictly greater than. So yes, on this one, if you see 0, 0 is in either, this one's in the region underneath, sure, let's plug that in and we'll see, are we going to shade towards 0, 0 or are we going to shade above that point? So if we plug it in, 0 minus 4 is negative 4 on that side, is greater than, we're going to have negative 2/3 times 5, which is negative 10/3. Is negative 4 bigger than negative 10/3? That's like 3 1/3. Is negative 4 bigger than, this is negative 3.3 repeating? No, that's smaller. So am I going to shade on the side where I plugged in 0, 0? No, I'm going to shade above that. So I'm going to go to all these points and I'm going to go up. I'm going to be shading in this direction. And I knew I was going to be shading up because y is the only variable on that side, and it's y is greater than, okay, even though it's y minus 4, is greater than, okay, so I know y greater than, I'm going to be shading up. So once I know which side of the line I'm shading on, I'm going to make sure I shade that entire region. Now, is 0, 0 part of your solution? No. Is -4, -2 part of your solution? Nope. I see a lot of heads shaking no out there. How about 0, 6? Is 0, 6 part of your solution?
Yeah.
Yes, that right here is part of your shaded solution. How about -2, 2? So this point right here, is that part of your solution? No, because it's a part of a dashed line. If it's part of a dashed line, we answer no. Is that okay? You're going to have to know how to explain it. On your quiz this week, I am going to ask you, is such and such a part of your solution? And you have to look at the point, and you either can do one of two things. You can plug it in and show me that you get something like this, okay, a number compared to another number, and tell me it's not true, so it's not a solution. Or you can tell me it's part of the shaded region on your graph. You can tell me it's part of the not shaded region on your graph. Or you can tell me it's on the dash/solid line, so it is, yes, a solution or not a solution. Okay? Does that make sense how we would explain those? So there's a couple different ways you can explain, but on this week's quiz, you will have to explain those. All right, so this next one, it's in standard form. So 2x plus 3y is greater than or equal to 12. Okay? So the easiest way I find to do these ones, especially in this case, is to find the intercepts. Okay? You could move it around to have y compared to, right? Y is equal to, you could think about it as an equal sign. And subtract your 2x on both sides and divide everything by 3. Or you can just find your intercepts. So if I plug in 0 for x, this term goes away. 3 times what number gets you 12? So, no, it should be positive. 3 times 4 gets you 12.
Oh, thought there was a negative sign. Oh, okay.
Okay, if I plug in 0 for y, 2 times what value gets you 12? So those are going to be 2 points on your line, 0, 4. So not left or right at all, but we're going to go up to 4. Right to 6, not up or down at all. Here's a point exactly in between. I'm going to fill in more points here. Will I connect this with a solid line or a dashed line? A solid line. Okay, now am I going to shade up or down? And if you're not sure, plug in a point. What's an easy point to plug in? What's the easiest point to plug in? 0, 0. So if I plug in 0, 0, this point right here, I would have 0 plus 0 is 0, is greater than or equal to 12. Is 0 bigger than 12? No. So I know 0, 0 is not part of the solution. So that means I'm going to be shading up on my graph, above the line. Give me a 1 through 5. I'm totally with you. I get where we're shading. I understand if I'm connecting with a solid versus dash line. Down to a 1, I have no idea what these points are, why we're coloring graphs. I'm not in kindergarten. I don't need to color. Who doesn't love coloring, though, right? I like coloring. Brand new set of crayons. Best thing ever.
I'm almost afraid to use the crayons because I'm like, oh, they're so nice. Like, I don't want to use them yet. So I just put off using them until the last moment because I like seeing them perfect.
All right, so number 4. This one is just less than. So negative 2y is less than x minus 8. Okay? Now, we might have to change this one, and this should not have an equal sign there. We're going to have to change it and solve and get y alone. What are we going to have to do, though, to get y alone? Because right now it's being multiplied by negative 2. Divide by -2. So this is the tricky part. What happens when you divide by a negative in an inequality? What happens to our sign?
It flips.
It flips. So you can't forget to flip your sign here. Okay, that will throw off your whole graph if you forget to flip your sign, which you don't want to do. So y will be by itself. Okay, your sign is going to now be greater than instead of less than. This was a 1 in front of here, so we have -1/2 x. -8 divided by -2 is +4. Now this is a lot easier to graph because that's just in slope-intercept form. So what's the very first point that you're going to plot here?
0, 4.
0, 4, which is right here on our graph. And then how do we use our directions to go from there? Down 1, right 2. Down 1, right 2. And our scales here are just 1, so that makes it a little bit nicer. Do I connect it with a solid line or a dashed line? Dash this time. And if y is greater than this, how am I going to shade? Am I going to go up or am I going to go down? If y is greater, where's y greater? Up. Y goes greater as you go up. So it's going to be up. Now we could always test it by plugging in that 0, 0 point. If I plug in 0, 0 here, I'm going to have 0 is less than -8. Is 0 less than -8? 0 smaller than -8? No, so I don't want to shade on my 0, 0 side, which is why I'm shading up. So you can always do it either way by plugging in at 0, 0 point. The only time it gets tricky is if 0, 0 is actually on your line, then you don't have a way to shade. So if 0, 0 is on the line, you got to pick a different point. All right. Is 8, 0 part of your solution? The point 8, 0, is that part of your solution?
No,
Why not?
because it's on the dash line.
It's on a dashed line, and dashed is not part of your solution. So 8, 0 is on the dashed line here. That's not part of your solution. Are you with me?
Yes.
All right. Let's keep going. Number 5. This one's also in point slope form. This one will be greater than or equal to. Okay. What point was used to write this equation? Go ahead. 4, 2. Remember, there's your x with the x. It shows up opposite, so 4. Here's your y with your y. It shows up opposite, so 2. What's your slope that was used? 3. So we're going to plot 4, 2, which is right here. And our slope is 3. So be careful because the scale here on your y is up by 2s. So up 3, right 1. Down 3, left 1. Down 3, left 1. Am I going to use a solid line or a dashed line? Solid. Here's my solid line. Now it says y minus 2 is greater than or equal to. So is greater going to go up or down? Where's y greater? Up or down? Up. Y is greater going up. So we're going to go up here. Now we could test it. We could plug in 0, 0. Is 0, 0 supposed to be part of the solution? It should be. So if I plug it in, I'm going to get -2 on this side. I'd have 3 times -4 over here. Is -2 bigger than -12?
Yeah.
Sure is. So cool. 0, 0 is supposed to be a solution. I can see it's a solution. So what I'll do is I'll color in that half of my graph with a different color. because I dropped my orange. So anything in this blue region, anything on that green line, any of that is part of this graph, this solution. Next one, less than sign. Negative 3x minus 6y is less than 9. My y-intercept, 0. If I plug in 0 here, that term goes away. Oh, that's okay. All right, divide both sides by negative 6. Y would have to be what? 9 over negative 6, but that reduces. Yeah, 3 over 2, so negative 3/2. Okay, plug in 0 for the y. Negative 3 times what gets you 9? How about negative 3? Negative 3. Okay. So negative 3 zeros right here. Negative 3/2, well, these are going up by halves. So it's negative 1.5. Now that you have those 2 points, you can connect them. How are we going to connect them? With a solid line or a dashed line? Dashed. You could add more points if you can. I think this would be a point here. Nope, it wouldn't be. I lied. I can add another point down there, though. All right, so dashed line. There's my dashed line. Now, let's test a point. Will 0, 0 work? Is 0 less than 9? 0 is less than 9? Okay, so that means the 0, 0 side should be shaded. So going this direction. Now notice that sign looks like less than, right? Usually that means we shade down. So be careful, because if both your x and y are on one side, that sign's not going to show you what way to shade. If it's y compared to the equation, it'll tell you which way to shade. But if you're x and y, pick a point and check it. Okay? Because sometimes it gets tricky that way. So this shading is going to be above the line. And we could test other points. They will still work. But 0, 0 is the easiest point to check. Okay. One more. And the reason I did all of these with linear equations is because our last couple days we've been practicing graphing absolute value equations. So that should be fresh in your mind. We will do another one as well. And there's one that we have to actually talk about too. If you have something like this though, where it says x is less than 4, okay? How would I graph x equals 4? Because for some reason, this is something that people tend to forget. How do you graph the line x equals 4? Yes, this is one of those special lines. If you only have one variable in it, remember I told you that the 3 key components to being an equation is it has to have an x, it has to have a y, and it has to have an equal sign. If it's missing one of those 2 variables, it's either a horizontal line or a vertical line. This is x equals, so it has to go through the x-axis at 4. So that would have to be a vertical line. Now because it's less than, we're going to use a dashed line. So we're still making it a vertical line. It's going to be dashed. Now this is the only one that you cannot put your arrow going up or down for the shading because your line goes up or down. Okay, so if it is x, That's the only time your arrows will go either left or right. So where is x less than 4? On your x-axis, that moves left to right. That's why we're comparing it with a left or right arrow. Where is x less than 4? To the left of 4. So we're going to put our arrow going this direction. And now we know that our shading has to be this whole region of the graph all the way to that dashed line. Okay. Okay, so here's my question. Because you guys are practicing these with absolute value functions as well, what is the difference between these two equations? There is a difference. Go ahead.
So if you were to put, for the first one, if you were to distribute it, it would be -2 instead of where the other one is -1.
You can't distribute across an absolute value bar, though, because absolute value bars are like brick walls.
Not bad.
With an absolute
I have no
value, you're
idea.
gonna deal with the middle first, and then you're gonna multiply, right?
Yes, that is true if you are evaluating. But how do you find the vertex? How do you find the vertex of an absolute value function? What do we do to find the vertex? Go ahead.
Set the absolute value to 0.
Yes, so x minus 1 equals 0. What is the x value then going to be for your vertex here? X is what? 1, right? Add 1 on both sides. So you took the inside, x minus 1, you set it equal to 0. You find x is 1. So our vertex is 1, comma, let's find the y value. Let's plug it in. 1 minus 1 is what?
0.
0. What's the absolute value of 0? 0. What's 0 times 2? Still 0, plus 7. So we're at 1, 7 for that vertex. Let's figure out where this vertex is. What do I set equal to 0 this time? The 2x minus 1. So you're going to have to add 1 to both sides, then divide by 2. Your vertex is at 1/2, comma, all right, we're going to have to plug it back in. 2 times a half is, well, 2 times 1 is 2, divided by 2, you're back at 1, right? 2 times a half is 1. You have 2 halves, that's 1. 1 minus 1 is 0. What's the absolute value of 0? 0 plus 7 is 7. So your vertex is located at 2 different locations here. Okay? So if that 2 is on the inside, it's going to affect your vertex, where if it's on the outside, it doesn't affect your vertex because you set the inside equal to 0 to find the vertex of your V graph. If you have absolute values, you know your overall graph has to be a V or the mountaintop, the upside down V. How would it be an upside down V? If there was a negative out front of the absolute value bars. Okay? Once you have that vertex, then you know that I'm going to put 1, 7 in the middle of my graph, or in the middle of my table, and I'm going to find points on both sides of it. So -1, 0, 1, 2, 3. Find more points, and then you can plot them. And then from there, you'll have to say, am I shading, if your graph looks like this, maybe it's dashed. You have to ask yourself, are you shading up or down still? It'll be y compared to, so if it was y is less than 2 times the absolute value of x minus 3 plus 1, that is the equation for this. Okay, if it was y is less than, I know that I'm shading down from those points. Down from those points means all of this will be shaded, not above the V. Okay? Does that make sense? So I know we did not practice many of those, but that's because we already practiced graphing those today. Okay? So the rest of the time is yours to wrap up the 2.6 and the 2.7 assignments.